Good evening.
Welcome to the show.
Hello.
On tonight, shouldn't we? Well, we don't think it's going to be very long tonight because the lesson for this one is really, really easy. And I think, Jack, you're going to do the lesson, aren't you, again?
Yeah, but it shouldn't take too long. It's like 15 minutes, if that.
We're literally sitting backstage going, what can we do with this lesson? None of us could come up with anything.
There are shows that I like that, though. I've hit slumps where it's just like, there's nothing I want to play, there's nothing I want to do, like, there's no point in going forward unless there's some,
Yeah, it's really difficult, and
I mean,
the basics really for mod. Well, it depends what you're going to use this for, but I mean, we're sort of setting our sights on those like the model makers and that want to do stuff, and it's apart from playing around with LEDs, which we've done quite a bit. It's really difficult, to work out how to implement this lesson tonight. So
well, I'll tell you what, I'll go through the chat and then we'll get on with the lesson. So first of all, tonight we have D Harris saying evening Alex, Mark and young Jack. So evening. And then we've got Jay's channel. Good evening all, hope everyone is okay and well. Good luck with your show and have fun. So hi Jason. We've got Jay's channel saying my Raspberry Pi has arrived. Look forward to my project on that.
Nice.
Awesome. Hi Jay.
Hi Jason. And then we've got Dano's Universe. Hello everyone.
Hi Dano.
Hi Dano. And then we've got Yorkshire Crafter. Hello everyone. Hi love.
Hi Julie.
Hi.
And then we've got Dave Matt Builds. Good evening everyone. Hope all is okay. Good luck with your electronics tonight, guys.
Thank you.
Thank you.
And then we've got Geordie Dave saying evening everyone. Evening Geordie Dave.
Evening.
Hi Geordie.
And then we've got DS Models and Vintage. Hi everyone. Good luck with the show. Thank you, Dave.
Dave.
Hi Dave.
And then we've got Yorkshire Crafter saying hi at Dave Matt Builds and at Jay. And then we've got Dave Matt Builds saying hi Yorkshire Crafter. And we've got Dave Matt Builds saying it's been another glorious sunny day here today. It has been here as well.
Yeah, it's really warm.
And then we've got D Harris. A good evening all in chat. And then we've got D Harris saying evening all.
Evening. And
then we've got Matthew Borum. Evening, friends. I'm isolating. Guess why? I don't think we need to guess that one. Dave Matt Build says evening, D. D says at Dave Mac, a good evening, sir. Yorkshire Crafter, evening at D Harris. And D Harris says at Jay's channel, at Yorkshire Crafter, good evening, both. And that's the chat. Okay, right. Your turn, Jack.
That's me. Right.
Go your solo layout.
This one, no. I don't even know what I clicked.
Jack, it's the little thing above your head.
No. I know what I'm doing. I know. Right, yeah, right. I know what I need to do now. This. Sorry. Right, here we go. Right. In tonight's show, we're doing the tilt ball switch. In this lesson, you learn how to use a tilt ball switch in order to detect small angle of indication. So when you have this is the switch thing. When it tilts upright, something should happen, and when it's down, something else should happen, either turn off or on. And you can hear there's like a little ball inside. In tonight's lesson, will be required the Arduino, the tilt ball switches I've just showed, and the male to female wires for the third lesson in a row. Tilt sensors, tilt ball switch will allow you to detect orientation or indication. They are small, expensive, low power, and easy to use. If used properly, they will not wear out. Their simplicity makes them popular for toys, gadgets, and appliances. We were talking before the show, weren't we, about what they could actually be used for in like part works and whatever.
Yeah.
Yeah, I mean, I said they do use them in fish tanks, especially marine fish tanks, when the water drops low. The tilt switch will then activate and it will top up, switch on a pump that you've got underneath with more water in it and fill the tank back up again. So that's how they can work as well.
Yeah. Sometimes they are referred to as mercury switches, tilt switches, or rolling ball sensors for obvious reasons. I think the mercury, isn't that for like a thermometer? Thermometers use mercury.
Yeah, I believe so. Yeah. Well, it used to. I'm not sure if it does anymore because it's dangerous, isn't it?
Yeah.
Yeah.
So they are usually made up of a cavity of some sort. Cylindrical is popular, although not always cylindrical, with a conductive free mass inside, such as a blob of mercury or rolling ball, which is what's inside, which is what you can feel inside. One end of the cavity has two conductive elements, poles, so one either side. When the sensor is orientated at that end is downwards, the mass rolls onto one of the poles and shorts them, acting as a switch. So one pole, so the ball goes to this side, then it'll activate something that's on this side. And if it goes to this side, it does this side. So that's like a on and off switch. So it's still true or false. It's still just true, false, or While not as precise or flexible as a full accelerometer, tilt switches can detect motion or orientation. Another benefit is that the big ones can switch power on their own. Accelerometers, on the other hand, output digital or analog voltage that must be analyzed using extra circuitry. So this is the schematic for tonight. The one wire will go into ground, the negative, and then we have, I think it's pin 2. Yeah, pin 2. But I don't think there's a negative and positive on this. It doesn't say that there is. Or
no, because it just works on continuity. So yeah, you can wire this any way you want.
Mm-hmm. Mm.
So this is what it should look like on, well, close to Tinkercad. That's what it should look like. Right, the code. After wiring, please open the program code folder. Lesson 8. Yeah, we have that. This is what it actually looks in real time. I can, if I switch my camera now to this. Oh, I don't know why I did that. Still need to get used to this. No, wrong one.
I'll do it. There you go.
There we go. I still don't know what I'm doing. As you can tell, I don't use StreamYard. So this is what we have. Just four components like it was like it's been for the past 2 weeks. Quite simple. The red one will go into pin 2. No. Red one will go into pin 2 for this one. And just going one side of the buzzer, not buzzer, the switch. Yeah. Then this one will go into ground. My head's in the way. Can I have to see what I'm doing now? And then it goes into the other pin. The pin will be, the 2 pins on the switch are really close together, so you have to have them like, you have to have it like lined up at the female point of the wire. So this is what it looks like wired up. And then I would go to the code. Yep, here. We go to the code here. Plug the Arduino in. I've already uploaded it because I had to test it before the show. But it's the same as what we've always done. If you're new, then it's just you load the code from the lesson, and then you upload it. So okay, right. I've already uploaded it to Arduino, but I had to unplug the USB. It's fine. But yeah, what it does is, like, if I go back to solo layout, no, that's Why does it keep doing that?
I'll do it. There we go.
I don't know how to switch it. That's what it is. So if you look over here, so if you look like here, there should be an orange light. So right now it's facing downwards. We move it up. You can see the orange light that goes here, like that.
Brilliant.
Yeah.
And just to show that I've done mine. So that's mine.
Yeah.
And there we go.
Nice. Yeah. Cool.
There we go. Brilliant.
Not too difficult this week. Not too
No.
difficult. Never really is.
Right. So shall we have a look at the code for this one?
Yeah, you can. Cause,
Right.
yeah,
So if I share screen. Share screen. One.
I think I've got an idea. I might try and edit.
Okay.
Right. So obviously we've got at the top constant LED pin equals 13. The LED attach. So that's the pin. The LED on the board.
Yes.
Then we've got obviously void setup, and then we've got pin mode, LED pin, output, initialize the LED pin as an output, so we're setting that as an output. And then we've got pin mode, we've got an input on 2, and then digital write on 2 high. So that's sending the power to the tilt switch. Then we've got void loop. And then we've got digital values, digital read. So then we've got digital write, LED pin low when the LED off. So it's obviously telling that it wants the LED off when it's low, and then put the LED on high, which is switching it on when it's on, when there's basic power going to it. And that's it. I think I read that out okay, didn't I?
Yeah. But yeah.
Yeah, it was all right.
By and large, that's what it does, yeah.
Yeah.
And it's quite interesting to see this bit of code, actually, because it's using the if and else statements, and it's in digital val is new to me. So it's obviously reading the value and obviously writing voltage to the switch rather than expecting it to go low. So it's a slightly different way of programming a switch, which could work out a bit easier, actually.
Yeah.
So I'm not sure you need resistors, because there's no resistors in line or anything.
The resistors might be actually on the board, though.
Yeah, you're right, but it doesn't state pull up, which would activate them. So yeah, it's quite interesting.
Okay.
But yeah.
Well, that is today's lesson done with. Next week, we will be doing servo motors.
You're doing the show next week.
I don't mind doing it next week. We're doing servo motors, which for me, I'm a massive RC fan. It's right up my street, is that. Really, really is. So I'm really looking forward to that one. Right, I'll just catch up on this chat and then we'll go over to Horlixs. So D Harris says at Jordy Dave at DS Models and Vintage, evening both. And then D Harris says evening at Dano's Universe. And then we've got DS Models and Vintage saying evening at D and everyone.
Hi, Dave.
We've got Steve131. How do, young man? I'm 41. Nobody believes I'm 41.
That's a good thing.
Yeah, I suppose it is a good thing. And Jordy Dave says hi at D Harris. And that's the chat caught up with for now.
Hi.
Hi. Right, just off the cuff, we can do a bit of small editing. I think we can try and change this code to operate 2 LEDs. I'm not sure it's going to work, but I'm going to try and put a timer on it as well, so that when you flick the switch, it will stay on for a set amount of time. So let's try that. But before I do that, I'll show you an example of...
Look, pull your full screen. There we go.
I'll do an example of what we could do. This is what we did last week. And it still works. It plays as we did last week. So what we can do is I've got my tilt ball switch here. Okay. Yeah. And you can hear the ball in it. If I just plug this directly into where I've programmed this switch, oh, there you go, like that. Obviously, when I lift this up, it will start, and then when it's down, it won't. So you could use that in like, I don't know, if you had like a toy or anything or something you wanted, you know, if you lifted it up, it would activate. So that's the sort of the use you could use that for. All right, calm down.
Maybe like something like you shake that makes a noise.
Yeah. You just have to touch it, really.
Mm-hmm.
So that's yeah, that's another use you could have for it. So I'm just trying to think off the cuff what we can do just to edit this code. So let me go over to my screen, and then we will. Where are we? This one. Share. So let's have a play, shall we? So let me delete some of this out because we don't need all this in. Right, so let's change the LED pin because we don't want to use the one just on the boards. So we're going to rename these as well. So let's do, oh, let me just unplug that because that's going to be going off. Let's change that to LED 1, and we'll change that. Let me have a look at the board here. So I'm going to have to wire this in. So let's change that to pin 9. LED 1 is going to be pin 9. Okay, then we're going to do same again. Constant int LED 2, and then we'll do that in pin 10. Is that 10? Yeah, we'll do 10. Okay, so then we're going to want to add a pin mode in and change this name because we've referred it as LED pin. So we're going to change that to LED 1. We're going to mark that down as an output. So this is just a comment, so we can edit that. And then we're going to do pin mode. And we'll do LED 2 because we want to add another LED. We're going to mark that as an output also. Well, not an outputee, an output. Okay.
Mm-hmm.
Okay, then that's it. So pin mode 2 is for the switch. So we'll keep this switch. Actually, let's change the switch value because I've already got a switch plumbed in, and it is actually in pin 2 anyway, so that's handy. So that can stay as that, and that can all stay as that. So what I want to do now is change this. So this can all stay digital value because we're reading the switch on pin 2. And then if high, so this is going to stay. We're going to digital write LED pin. Oh, there's a lot of action going on around here tonight. Digital write LED 1 low, which is fine. Then we're going to do digital write because we need to take the other LED into account. And we'll do LED 2 And then we'll do that low. So turn the LEDs off. Okay. So then what we can then do is tell it to, let's turn the LEDs on. So we're going to do digital right, LED 2, and I need to change that top one. I was going to leave it, see if anyone had learned anything. But
it's all right.
LED 2 high. Okay, so that is all we've done is just added an extra LED. So we're going to turn 2 LEDs on, and we're going to then turn 2 LEDs off. That should be it. So let's go back to my desk. We'll plumb that in as it is, and then we'll upload it and see if we're getting the desired result. And then what we can do is we can add it. We can change the code a little bit more afterwards. So I'm going to leave that plumbed in there because that side of the circuit is absolutely fine because that is going to pin 2. So this is the other one which can come out. And the tweezers for this. So what I'm going to do is add the LEDs. So let's go resistors first. There's one, and then I'll put the other one up here somewhere. And I'll put the resistors to positive, I think, so then we can attach the LED pins to this. So we set it as 9 and 10.
Yeah.
There we go. Then we want ground feeds to the LEDs. So we're going to do, let's put an LED in there. Short one is earth or grounds. So I'm just going to run the earths down. Remember, we're going across the board here, so we're going to have to jump that. So it goes from the earth on the end down into this route and then down into this one here.
Mm-hmm.
Oh, what did I say? Short's earth, isn't it? Oh, God.
Yeah.
Yes, long is positive, short is negative.
Lovely. Right, okay. We need to get some more jumpers.
Oops. Sorry.
Put that one over into there. I'm actually going to have to move this resistor over one.
Uh-huh. Yeah.
Oh. Move that pin over one. Right, okay. LED can go into place there now. Right, check my connections. We've got earth down into the LEDs, positive up to the pins. That is going to button 2.
I think everything looks good.
I think that's good. I mean, I'm questioning now the setup on the Switch because... Oh no, that should be fine. No, that's fine. Yeah, so hopefully, if I write this code now, we should get no lights. So let me plug in and upload. Right, I'm just going to upload now. You'll see these lights flicker when I'm uploading. Oh. What's gone wrong? Something's not right.
You want to share your screen and see if we can work it out?
Oh, yeah. I haven't done anything. Right. That's what I've done. Well, I forgot to put a semicolon up there. Right, done. So let's upload. That should go. So let me come back. I'll upload that again. See the lights blink. So hopefully, if I lift that switch, both these LEDs should come on.
Yeah.
Now, one's actually dimmer than the other, but I think that's because it's a different resistor. As I said, like, I've got about a load of resistors in here. I'm not sure what the values are, but yeah, they both come on. So and then when we flick that, they'll turn off.
Nice.
So what I'd like to try now is timing it so that they stay on even though we've released the switch. So I think the simplest way I'm hoping to do this is just right here, delay, and then we'll do it in milliseconds. So, you know, obviously if you're going to do a project, you might want it on for 20 minutes, 10 minutes. Obviously, I'm not going to sit here for 10 minutes to test it. So let's just do like 10 seconds or 20 seconds. So we'll do 20,000. There we go. And then semicolon. So hopefully that'll turn the LEDs on and then keep them on for 20 seconds, even if the switch is dropped off. That's the plan. So let's upload that and see what result we get. Well, that's gone on all right. So now we're going to lift the switch and drop it. There you go. So that they are now going to stay on, even though the switch is off, for about 20 seconds, and then they should go off on their own in a moment. Unless it's laughing at me, going, no. There you go. So you could implement that in a kit, like if you didn't want the batteries to die or were showing it off, or you wanted it on for a short amount of time, you can just flick your model, make the lights come on, and then set the delay for, I don't know, 20 minutes, half hour, depending on your power source, obviously, because you'll drain batteries. But that's just one of the things you could implement, and that was a really simple bit of code. Really, that was really easy. So just to recap, all we did was add another LED to the circuit, tell it what pin we're in, tell it that it's an output. Didn't have to touch any of the switch values because that had already been done for the lesson. Then we just had to add the extra code to tell it to turn the LEDs on and off, the extra ones. Because remember, you're referring this LED 2, and that is basically LED 2 there is looking up this line up here. So that's why it's really important to name everything exactly correct. But also it helps you identify things for problem solving. And then we've just literally stuck a delay on the end. You know, and you can change that for whatever time you want. So we could do 1 second if you like, just to show. So we'll go up, change that to 1,000. Come back to desk view, and that should literally come on for a second. There you go. So
Nice.
that's just a bit of basic on, yeah, how you would perhaps have a delay, or, you know, if you wanted something to do something when moved, that would be a perfect system to do that with.
Yeah.
So yeah, you know, I had this great idea of, I don't think it would work. No, because about 45 degrees it will start activating. So you can't even do that. But I had this wacky idea of like strapping one of these switches onto a clock face, so that when it actually got to on the hour, it would do the cuckoo or something. But yeah, obviously, you know, it's going to be cuckooing off at, well, probably about 1:45, 10, 5:02, 10:02. But yeah, that's all I've got really for you today, I'm afraid. Nothing too exciting, quite basic, but it's nice to go back to basics sometimes, because I'm hoping for you it'll be a bit more understandable for those that are really new to this. So yeah.
Well, you got to think, we all have tilt switches in our homes, and it's in your toilet system. Because once that falls before a certain level, it activates the water to fill back up again.
Well, yeah, basically, it's like a non-electrical version of one of them, yeah, because it does it on a flow. So yeah, it's the same sort of principle and ish.
Yeah.
But yeah,
Okay.
no, that's. I hope that was all right for you. Say it was quite a short show today, really, but it's difficult to know, you know, what to do. I mean, I could do all sorts with this, you know, but that's a basic principle of, like, basically implementing the switch to power more stuff, but at a delay. So that's sort of what I was going for.
No, yeah, like you said, sometimes it's good to go back to basics after going into like RGB bulbs and other bits and pieces, and yeah, it's just
especially last week's show. I mean, I'm not expecting anyone to have got that, and a lot of it was copy and paste, but it's just sort of not necessarily that you're going to do that, but just to show some of the things it can do, really. So, yeah.
Okay, we've only got one little bit of chat in there, and that's D. Harris saying at Steve131, how's you, fella? That's a bit of chat at the moment. So I think that we've covered everything for tonight, really.
Yeah.
I'm trying to think if there's all else. I don't think there is.
No.
Like I said, next week is servos, so that's going to be interesting because you can put them on your models.
Yeah, and as I saw, like there is I saw this great mod. Someone had a, they basically had I think it was a train set. They had like a model railway set up, and what they had, it was amazing. They had like a ramp that came up and then went level and then came onto like some yard, and all they had done, really simple, they had like a little mini forklift on the top, and what they used was a servo underneath the panel with a really strong magnet on it attached to the arm, and then obviously the receiving magnet was on underneath of the forklift. So when the servo moved, it moved the forklift without seeing any electronics, or it was just like a floating forklift that was moving up and down this ramp, and it was absolutely fantastic. It gives you, for such a basic thing, it gives you so much, you know, awesomeness, if you like.
Well, we like servos with train tracks. You could actually do like a show with it, so you get different points to go off at different times and stuff to switch the track. So it sort of does an animation, if you know what I mean.
Yeah.
Of the train track and using all of it, and when other trains can go off and stuff. So
yeah, because if you timed it right, yeah, as you say, you could set it as a program and you wouldn't have to do it. So if you're at a show or something or a rally, you could have your train going round and periodically program it to change points. You could even add you could even get really technical and add like a sensor so that it knew when the train had passed. Then it changes bits and stuff. You know?
Well, there's them motion sensors in these as well, isn't there? So we'll be checking out them soon in the lesson. Yeah, right, so we just had another bit of chat come in. Dave Mac Build said, great show tonight, guys. Thank you, Dave Mac. Like I said, it's a bit of a short one because it's just such a simple lesson, really. I'm sure they'll get harder and harder as we go through. So, yeah. Right, shall we end the show then and do us goodbyes?
Yeah.
Yeah, do you want to go first?
Yeah, thank you for watching. Obviously, it hasn't been a very particularly long show tonight, but obviously, if there's nothing to stream, then there's no point, obviously, streaming it. But yeah, if you haven't already done so, please make sure you are following and subscribed and all that lot. If you do enjoy the shows, so you don't miss out on another one. And yeah, thank you everyone for sticking around till the end.
Yeah. Horlixs?
Yeah, lovely. Thank you very much for watching. So yeah, sorry it's such a short show, but I managed to pluck. I'm lucky I plucked that out because I'm sitting here going, oh my god, what am I going to do with this? Apart from show you what I did from last week with it, that would have been the show over by then. But then I quick thought, I thought, right, I'll edit the code. We'll add some more bits. So it went really well.
Yeah.
So thanks all for watching, and yeah, see you next week. It's a bit more intense, servos, to be honest. I think just a little bit more, and there's a lot of more programming to do, but we'll see what we can do with that next week.
Yeah, definitely. Right, I'll just go through these last bits of chat. So D Harris says, short and sweet, but still a good show. See you again next week. Thanks, D.
Thanks, D.
Thanks, D.
And then D Harris says, night all in chat. D Harris says, night all in this chat. See you all next week. And DS Models of Vintage says, good show, guys. Thumbs up. Bye to everyone in chat. And I'll just say thank you, everybody, for tuning in on this very simple show tonight. I've quite enjoyed it because it's been simple. And, you know, sometimes keeping things simple is the way to go. But, yeah, so it's a good night from me. And we'll catch you next week when we're doing servos. So,
Bye.